Hi guys, today we're going to take a look at graphs of real-world situations. So we're going to take all that information we've learned about domain and range and see how it applies to situations in everyday life. So this graph shows the relationship between time and the depth of water in a leaky swimming pool. And if we look at our x-axis right here, our x-axis is being measured in time in hours, and our y-axis is measuring the depth, which is in feet. So if we look at the domain of this graph, the domain goes from 0 to 16, and the range goes from 1, which is our lowest point, to about maybe 3 2/3, 3.3 to our highest point. So we're going to be looking at domain and range in this graph, and what does it mean in a real situation? So question 1 is asking, what is the initial depth of the water? So we're looking right here, where is the water starting out the pool? The initial depth of the water is right there at 2 feet. I'm going to circle that, 2 feet right there. So for what time intervals is the water level increasing? So we're going to take a look at this graph a little closer and look at the increasing interval. So I want to know, when is the graph going increasing? So if we look here, it's pretty steady. It's decreasing right here, and right about 6 hours it's increasing, and it stops somewhere between 10 and 11 hours. So our increasing interval will be somewhere between 6 and 10, 11 hours. Why do you think the water level is increasing? Well, it could be that they're filling the pool. We said it was a leaky pool. Or that there's people in the pool. Letter C, for what time intervals is the water level decreasing? So again, we're going to look at this right here. Here it's steady, and it starts to decrease somewhere around 2 hours, and it's decreasing to right about 6 hours. So the time interval that the water level is decreasing is between 2 and 6 hours. There's also another decreasing interval, and somewhere around 11 hours the water in the pool starts to decrease as well. So between 2 and 6 hours, and also between 11 and 16 hours. Letter D, why is the water level decreasing? And we said that there was a leak in the pool. So is the pool ever empty? So we're looking at this graph and looking to see, is the depth ever 0? And the depth of the water never gets down to 0. Our minimum range is 1, so it never gets down to 0. So is the pool ever empty? No, because the depth never reaches 0. So what we want to focus on these notes is the dependent and independent variables. So in this example, the depth of the water is a function of time. And what that means is that the depth of the water depends on how much time has passed. So in this case, the depth of the water is the dependent variable, and time is the independent variable. And when you draw a graph, you always put the independent variable on the x-axis and the dependent variable on the y-axis. On the graph of this function, you can see you can see the domain values that are possible. And this is something that's called the practical domain. The practical domain just means what numbers make sense in this situation. So it wouldn't make sense to have x values or time that is negative. So practical domain is the set of all instances of time from 0 to 16 hours. And we can express this as an inequality where x is the independent variable representing time. So it wouldn't make sense to have, negative 50 because we don't have negative 50 hours. But we do have hours from 0 to 24, 0 to 16 in this case. You can also see the values that are possible for the dependent variable. In this example, the range is the set of numbers between 1 foot and about 3.3 feet. And we can express this also as an inequality. 1 is less than or equal to y is less than or equal to 3 3/10. Notice that the lowest value for the range is 1 foot. It does not have to be the starting value when x is 0, which is at 2 feet. So again, when we talked about maximum minimum, what's the lowest point of the depth in the water? And that is 1 foot. What was the highest depth of the water? And that was 3.3 feet. So the relationship between the independent, and that's always x, and the dependent, which is always y, variables, and the dependent variable is not always a cause and effect. Relationship. In many situations, time is an independent variable. It's the independent variable in graphs such as population growth or car depreciation, and in several relationships of this form, like time-distance graphs. But time change does not cause a population to grow or a walker's distance from a given point to change. In class tomorrow, we're going to continue with some more of these notes, and we're going to practice with independent and dependent variables. So now it's your turn. On the graph below, name an interval where the volume is decreasing. And number 2, use the graph from question 1. What is the independent variable and how is it measured? So when you put your answer in, write in the independent variable, comma, and then how is it measured. Make sure you put your answer in on the Google form.